Imagine for a moment that you've been tasked with studying work-related stress across a massive, bustling hospital workforce. To get accurate results, you need to hear from the employees, but interviewing every single person is impossible. You have to select a smaller sample. If you rely on unguided random sampling, you run a major risk. Drawing 75 people at random might accidentally exclude an entire critical profession, like the doctors, leaving your study with a massive blind spot. The mathematical solution to this is the Proportionate Stratified random sample. By mastering this method, you can create a plan that mirrors the hospital's exact demographics, ensuring no group is overlooked in your data. We start by identifying the total population, represented by a capital N, and dividing them into mutually exclusive subgroups called strata. You sort your workforce into these strata based on a specific characteristic, such as profession, making sure no individual belongs to more than one group. In our hospital, we have 375 total employees. They are divided into 25 doctors, 150 nurses, 70 paramedics, 50 clerks, and 80 unskilled workers. Next, we determine our target sample size, or lowercase n. This is the total number of people we need to include to get statistically significant results without exceeding our budget. For this study, we'll target 20% of each group. 20% of our total population means we need exactly 75 employees for our final sample. Setting these hard mathematical boundaries first is critical. Without them, any further division will lead to skewed, unrepresentative data. Now we calculate the exact quota for each department. This ensures the proportions in our sample precisely match the total workforce. To find the quota for any stratum, take the subgroup size, divide it by the total population, and multiply by your target sample size. For the doctors, we take their subgroup of 25, divide by 375, and multiply by 75, giving us exactly 5 doctors. Following that same formula for every department, we get our remaining quotas: 30 nurses, 14 paramedics, 10 clerks, and 16 unskilled workers. If we sum those quotas up, they equal exactly 75, matching our original target. This step ensures your sample is a mathematically scaled-down microcosm of the hospital, maintaining the exact demographic balance of the entire facility. With the quota set, we now select the specific individuals to fill them. Beware of convenience bias. Surveying the first 5 doctors you find in the break room ruins the math by selecting people merely because they are accessible. To do this correctly, you need a sampling frame, a complete numbered list of every single person within that department. We then use a random number generator to pick our participants from that list, selecting our 5 doctors without bias. This rigor is necessary. A clerk's daily stress is very different from an ER nurse's, and you need to capture those differences accurately. Strict random selection within these proportionate strata is the only way to compare these vastly different groups without selectively skewing your results. You've successfully moved from a chaotic population of 375 down to a highly structured, representative sample of 75. We defined our strata, set the target, calculated the proportions, and randomized the final selection. The result is a sample that looks exactly like your hospital, just at a manageable scale. You now have a mathematically sound tool that ensures every profession is represented in the correct proportion. You're ready to collect data that truly reflects the reality of your workforce.